Well, hello again, and in this video we'll be discussing on quadratic equations. And as I said in the last video, I will not be doing graphical method of solving simultaneous, so I'm moving on to quadratic equations. Now, a quadratic equation is an equation that exists in this form: y is equal to ax squared plus bx plus c, where y is equal to 0. Therefore, this will be equal to 0. That means that whatever value of x rather that I have, if I input it, I am going to get 0. And where my a, my b, and my c are constant, and you should know that the value of my a, of my x rather, and my intercept, because I put y equals to 0. Like I'm finding the intercept. So I'm taking this question for example. I want to solve this quadratic equation, and there are three methods of solving quadratic equations, which are factorization method, completing the square method, and almighty formula. But we will be dealing with factorization method in this video. In the next video, I will talk on completing the square method and almighty formula. Now, assuming I have this equation, what I am asked to do is to find the factors or the equivalents of this equation. That's what I simply mean by solving quadratic equations. Now, to do that, I have to find which values do I have to multiply together, that when I take their product, I'll get this. When I multiply them together, their product will be equal to this. That's 2. That's the value of my C. And when I add them together, I get 3. That's the value of my B. So their product has to be the value of my C, and their sum has to be the value of my B. Now, if you studied cubic equations, you understand that cubic equations have their rules, and so do quadratic equations, though I will not dive into that deeply. So if I have 1 times 2, that's 1 times 2, it gives me 2. So the product gives me 2. So I have 1 plus 2 gives me 3. So so their sum gives me 3, their product gives me 2. So my factors are 1 and 2. And normally the highest number will appear first, the lowest number will appear second. So putting this, I have x squared plus, what I have done is I have factorized this side of the equation with these two, with 1 and 2 rather. So this gives me plus 2x plus x, that's same thing as 1, same thing as 1 by put x. This is not really necessary to show the 2, the 1 rather, plus 2 equal to 0. If I add this back, I'll still get this, so it's no big deal. So I'm just doing this so I can separate the two. Let me write it out clearly. So I can separate it, divide into 2 parts and separate it. The 2 parts are this side and this side. Now this side is going to give me x squared plus 2x plus x squared plus, x plus 2 equals 0. This is the second part. That is separation. Now if I'm factorizing this, the common thing among all of them is 2 and x. Now I will shift this x here and this 2 here. So I have x squared plus x plus 2x plus 2 equals 0. Now the reason I did that is so that I can easily factorize out x here and easily factorize out 2 here. So I can bring out x on one side and bring out 2 on the other side for simplification purposes. So this here gives me x. I'm factoring x out from this side. It gives me, I can factor x out of here, but I can't factor 2 out of here. So I have to arrange them respectively in how it will be easier, in the way it will be easier for me to factorize. Here we have x plus 1. That's for this side, because x times x gives me x squared. X times 1 gives me x plus, now factoring 2 out of this point gives me the same value here has to be the same value here. The same value here has to be the same value here. So x plus 1. Now, it has to be the same value and also has to correspond to this. If I say 2 times x gives me 2. 2 times 1 gives me 2. 2 times x gives me 2x rather. 2 times x gives me 2x, then 2 times 1 gives me 2. So it corresponds equal to 0. Now I will take this and this out to give me x plus 2 in bracket and x plus 1. If I expand this, I will still end up with this equation. I'm going to show you how to do that at the end. Equal to 0. I will break these two down to giving me x plus 2 equals 0, x plus 1 equals 0. From here, I can move my 2 to this side, giving my x to be equal to minus 2. From here, I can move my 1 to this side, giving x equal to minus 1. So these are the intercepts of my x, so that on the graph, here is y, here is y, here is x, and here is negative x. My intercept would be, I have minus 2, minus 1, and I have 0. My intercept will be on these 2 points. Good, moving on. I said I'm going to factorize this out, expand it for you to see. X plus 2, x plus 1. I'm going to go over this again so you can easily understand it. If I'm expanding this, in fact, I can even start from here. If I have x equal to minus 2, all I need to do is move the 2 here to give me x plus 2. Same thing with x equal to minus 1. X equal to minus 1. All I need to do is move the 1 here to give me x minus 1 equal to 0 equal to 0. So I join these two like this and it gives me 0. So, as I said, everything here must be equal to 0. So if I have my x here to be minus 2, if I put minus 2 plus 2, I still get 0. My x here minus 1. If I put minus 1 plus 1, I still get 0. So opening this up, I have x times x, x squared, plus x times 1, x, plus 2 times x, 2x, plus 2 times 1, 2, equals to 0. And it gives me x squared plus this, that's 1x plus 2x, 3x, plus 2 equals 0. So I still end up with this equation, x squared plus 3x plus 2 equals 0. Okay, I'm going to explain this all over again, or rather I'll take another example. Now, assuming I am given x squared plus 4x minus 5 equals to 0. Remember I said I have to look for what values or what numbers do I have to multiply together that will give me minus 5, and do I have to add that to give me 4, positive 4. That give me negative 5 if I multiply, and give me positive 4 if I add. So I have let me take this here. I have minus 1 times 5 gives me 5. 1 minus 5 gives me, this is minus 5. That's minus 1 times 5 gives me minus 5. 1 times minus 5 gives me minus 5. So minus 1 plus 5, minus 1 plus 5 gives me 4. But 1 plus minus 5 gives me minus 4. So I'm taking minus 1 and 5. So if I'm taking minus 1 and 5, I have x squared. Minus 1 is same thing as plus minus x, that's minus x, plus 5 x minus 5 equals to 0. So this is the, we add these ones together to get this. So minus 1 and 5. Factorizing my x out and factorizing my 5 out, I have here x minus 1. Here I have plus 5 x minus 1. These two have to correspond. And when they are the same, they have to correspond with this. and it does. So I will take this and this together, that is this x and this plus 5, and I have this one or this one, and they're still the same. X minus 1 equal to 0. So I separate them and I have x plus 5 equal to 0 and x minus 1 equal to 0. So that my x here will be equal to minus 5 when I move this over here, and my x will also, or my x will also be equal to, if I move this here, I have 1. So if I have the graph here, my intercept will be on, if this is y and this is x, my intercept will be on minus 5 and 1. So it will be something like, and 1. So those are the values for my x, and if you put any of these values as x equals to minus 5 and x equal to 1 into this equation, x squared plus 4x minus 5, I'm still going to end up with 0. So thank you for just for proving purposes, if I can, from the answers I can still derive this. If I have my x equal to 5, if I move my 5 to this side, it equals to minus 5, I have plus 5. My x is equal to 1, if I move the 1 here, I have x minus 1. Multiplying, I have x squared minus x plus 5x minus 5. So it gives me x squared minus 1 plus 5 is 4, plus 4 x minus 5 equal to 0. So it's actually the same thing. Okay, thank you very much, and that'll be all.